everyone. So today we are going to start a different classification strategy. Now we have already seen Bayes classifier, that was based on statistical method. Now we will be seeing distance based classification, that is k nearest neighbor classification. Okay. So in this lecture we will cover the concept of k nearest neighbor classification. How does this work? How does this KNN works? And why we need to use KNN algorithm? How to choose the optimal value of k? What are the advantages? What are the disadvantages of this KNN? And does KNN have the curse of dimensionality problem? We will be discussing these things in this lecture. Now the k nearest neighbor classifier to start with. So first of all, as I have already mentioned that we are discussing only supervised classifier under this in this course. So we have already seen under supervised classifier there are different classification technique. One is the statistical based, another is distance based, error based, then distance tree based. So KNN is also a we call it a k nearest neighbor classification technique. It is a type of supervised learning classification and it is very widely used to solve many classification problems. Okay. The KNN is a data classification method for estimating the likelihood that a data point will become a member of one group to another. What does that mean? See here, estimating the likelihood that estimating the likelihood that a data point will become a member of one group or another. Meaning, we try to find out the similarity index, as I have discussed in my last lecture, if I remember correctly. So when we suppose there are two different classes of data and we want to given a set of attributes, we want to find out each this set of attribute means this data, basically this observation belong to which class A or class B. What we try to find out how this set of attributes, this data is similar. This data is similar to which class? Basically, it is similar to class A or it is similar to class B. We try to find out its similarity index. This similarity, one way of finding the similarity index is by finding out the distance, Euclidean distance of this attribute values of this my test data point with the different classes, the object belonging to the different classes. So with the distance, where the distance is smaller, so definitely my test data will belong to that class. Okay. So that's what we estimate the likelihood that a data point will become a member of one group or another. It will try to estimate the likelihood. How we will try to estimate the likelihood? By finding out the Euclidean distance of this between these two objects, between these two observations. And based on this Euclidean distance, we will tell this data point, this test data belongs to which group. Based on what group of data point is nearest to it, we will classify the data based on the group to which this data point is nearest, and it is a distance based classification technique that we have already mentioned. So when I tell its distance, how do I find out the Euclidean distance between 2 points? Suppose my attribute sets are, there are two attributes in a tuple in one observation. Suppose there are two attributes. Suppose this is, suppose a point that is x1, y1 and another point is x2, y2. If I want to find out the distance between these 2 points, is nothing. This all of us know this, how to find out the Euclidean distance of 2 points. So if there is if the data is two-dimensional, that means if it has two attributes, this is how we find out the distance, that is x2 minus x1 whole square plus y2 minus y1 whole square root of this whole thing. So this now suppose if my observations or if my object has 3 attributes, if it is a set of 3 attributes, then we'll have to consider 3-dimensional. So this is how we find out the distance. We find out x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square root of the whole thing. Okay. So similarly, if there is a 2-dimensional, we will consider it as a straight line. If there is a 3-dimensional, we will consider it a 3-dimensional plane, and if it is more than 3-dimensional, then we will consider it as a hyperspace. So Euclidean distance in n-dimensional hyperspace. If the n-dimensional data points are this x1, x2 up to n, y1, then the distance between them is same thing. Whether it is 2-dimensional, 3-dimensional, 4-dimensional, 5-dimensional, it's the same thing. Just you have to find out the distance. Okay. Now How do you do it? Suppose for a given set of data there are two classes. Suppose we given observation are there are just two classes. Okay. Suppose here I have seen this is one class is this blue square which we see, this is one class, and another class this red color triangle which we see, suppose this is another class. Suppose we have two classes. Using this training data or this observation data, this data which is already we could observe. Okay, you can I am using the term training. If I will talk in terms of machine learning, I will use the term observed data if I will talk in terms of statistics. Okay. So, let me tell it is observed data. So, using this observed data, we want to know the class of an unknown point. Now, my unknown point here is this green circle. So, I want to find out what is the class of this green circle. How do I find out? So, we have plotted this. Suppose the data are plotted. Suppose since this each attribute has each observation has two attributes. So, we can very well plot it in a two-dimensional way. So, now this if I plotted the data, this suppose then plot takes this form. Okay. Now, what is the first step? Calculate the distance of all training point from the test point. What I will do is that I will calculate the distance of all these training points. How many training points are there? Here we have 3, 4, 5, 6, 7, 8, 9, 10, 11. Total 11 training points are there. So, I will calculate the distance of this green point from all these training points. What is the distance of this and this, distance of this and this, distance of this and this, everything, distance of this, all the distance. I will calculate the distance of all the training points. Okay, that is my first step. What is my second step? Find out k training points which are nearest to the test point. Basically, once I have calculated the distance, then I will arrange it in the ascending order. I have calculated distance, then I will arrange it in the ascending order, and then I will find out k training points which are nearest to the test point. I will come to what is k. Let us, k is some number. Then I will find out k training point which are nearest to the test point. Okay. Nearest to the test point means distance will be less. The k in KNN is a parameter that determines the number of nearest neighbors to include in the voting process. So, to find out, as I told you here, find out the k training points which are nearest to the test point. So, I will find out this k training point. Now, this k determines which k training points which are nearest to the test data point. This k will determine how many of this number training data will be involved in the voting process. Basically, this is in k nearest neighbor, we just it is a sort of voting process. How many of the point is, suppose there are, okay, we will see the example here. Let us not talk now. The test sample should be classified either to blue squares or to the red triangle. Yes, it has just two classes, blue square and red triangle. The test is either should belong to here or to here. If k is equals to 3, we have found out the distance, we have sorted in an order, and now suppose I have considered k is equals to 3. Suppose if I consider k is equals to 3, then what will k is equals to 3, that's nearest point, the 3, that means the 3 nearest point to the green circle. So, this k is equals to 3 means this portion, fine. And if k is equals to 3, it is assigned to red triangle. If k is equals to 3, what happens? There are how many red triangles that is nearer to the green point? Nearer to that green point, there are 2 red triangles, and however, nearer to the green point, there is only 1 blue square. So, that means what? When if we take the voting process, red will win because 2 will vote for green, and the only 1 blue will vote for green. So, red will win. So, now that means the green circle belongs to the class which has this red triangles. Now, if k is equals to 5, if I take k 5 nearest neighbor, the 5 nearest neighbor means this dotted circle you see. 5 nearest neighbor, in this case, how many red points are closer to green? There are 2 red points which are closer to green, and how many blue points there are closer to green? There are 3 blue points that are closer to green. So, in voting, who will win? The blue points will win. So, that means the green circle belongs to the blue square cases. Okay. So, if k is equals to 5, it is assigned to the blue squares, 3 square versus 2 triangle inside the outer circle. It does not consider the distance. Here if you see the distance, red is very near, the reds are very near. It is not that. We find out the nearest first nearest k, and then out of this k, how many the class which has more representation, the text data will belong to that class. Okay. So, when we have considered k is equals to 3, which class had more representation? Red class had more representation, that is it has 2, and blue class had 1. And when we considered k is equals to 5, our blue had 3 representation and red has 2 representation. So, our test data will go to blue. So, if I now, that is the step basically. So, now if I write down the steps, so first is load the data, choose the k value. How to choose the k value I will come. Now, for the test data point, find the Euclidean distance of all training data samples. We have done that. Store the distance on an ordered list and sort them in descending order. Sorry, it is a miss here. It is not descending order, it should be ascending order. Okay. We will store them in ascending order. So, and then what happens? Choose the top k entries from the sorted list. Okay. We will choose the top k entries from this the sorted list. Top k means, I should not say top k, but the nearest, the value which is less value. So, label the test point based on the majority of the classes present in the selected point. So, first what we will do, we will find the Euclidean distance of all the training points, then we will sort the data. How will you sort the distance? We will sort the distance in the ascending order. Okay. And then we will consider the top k points. Top k points means the points which are, the k points which are nearest to the, which has the smallest value basically. Okay. And then among this k point which has the major representation, our test data will go to that class. Now, this KNN is also called a lazy learner. Why it is called a lazy learner? Because you see, in all of the classifier or regression analysis, whatever we have done, regression and all, those are also prediction, classifier also prediction, all this is prediction only. Everything in all these cases, you see, we have developed a model. For all this, we have, once we get the training data, then we develop the model. So, based on that model, given an input, we try to find out what is the output. If it is a regression analysis, given x, what is the value of y, that is what we try to find out. If it is a classifier, given x, what is the class of this x, that we try to find out. Okay. Whatever it is, either it is regression analysis or classification, whatever it is, so or clustering. So, now there we form a model first, but in case of this KNN, we somehow do not form the model. So, we whatever test data is given, we just store the test data. So, from the statistical perspective, when the test data is there, it is just there, the test data, we do not do any sort of calculation, the test data is there. Okay, this data belongs to this class, this data belongs to this class. Okay. So, these data are there. So, that is why this process is called lazy learning algorithm. It does nothing when it does the, when it gets the observation, when it gets the initial observation, it does nothing. It only starts working when it has to test a data. When given an observation, we have to find out the corresponding class, then only it will start its action. Before that, it will not do any action. So, that means it does not learn any mathematical equation or model. It does not form any model. Instead, it just stores the training data and starts computation when the test data is presented. So, that is why it is called lazy learning algorithm. Now, KNN is also a non-parametric method because it does not make any assumption about the underlying data distribution. It is considered a non-parametric method because why when we consider parametric method, we have certain assumption about the underlying data. This data has to belong to this distributions. Now, here in KNN is very much a non-parametric. You don't have to bother about the distribution of the data, and that is the input data. That is the attributes of this different tuple. Okay. Simply speaking, KNN tries to determine what group a data point belongs to by looking at the data points around it. given it the observation, we have to find out it belongs to which class, this class or this class. You'll just have to observe this training, the different classes of data. Of the test data for test data, whichever we find as test data is nearer to whichever class, that our test data belongs to that class. Okay. So now the question is, how do we find out the k value? I have already specified that we sort the data, then we take the first k value, first k points to find out its nearest neighbor, first k nearest neighbor. Now the question is how to find out this k value. There isn't any specific way to determine the best k value. Okay. So there are different, empirically you can find out, take different k and find out the values. So one way how you can take it, you might have to experiment with a few values before deciding which one to go forward with. Means you will try deal with many values, many k values, and then you find, okay, this k value gives the better result, then we can go with this k. Now how do we find that, how will we experiment that, how many k values will take, and then which k is giving good result, how do we know? Because okay, in the observations, as it is the supervised learning technique, in the observation the class level is given. Now and for the different observation for which we have to find out the class, that is the test data, basically it doesn't have the class level. So if we are taking whatever k value we are taking for this test data, we are getting the correct value or we are not getting the correct value, we won't be able to say, because this test values data's class categories is not known to us. So only way is that if we can find out the base k value if we have some such data for which our class data is known to us. We have certain such data for which the class data is known to us, and then we fix a particular k, and then we try to for this data we try to see it belongs to which category and whether it is correct, because already we know the class level. Now our this result is giving the result what we expected. If the results matches, okay, then this is good. If the result does not matches, then something is problem, that maybe we'll have to change the k. That's how we do it. So that's what I have written here. So one way to do is by considering or pretending that the part of the draining sample is unknown. So the observation what is given to us, or let us say if it is a training data or whatever it is, the portion of it we will consider as if it is not known to us, means we have not stored those data. We will take it, a portion of this training data we will not store, we will just use a portion of the observation to make different classes. Now this other portion, which observation for which the class level is known to us, that we will try to put it into different categories taking different values of k. Using this subset of training data as test data, the true class levels are known in this test data. Here the true class levels are known. Perform classification using KNL algorithm and for different values of k. Okay. Check the classification accuracies for different k. Because these class levels are known to us. Suppose we know this data x1, x2, x3, it should fall in class A, it is known to us. Then again x4, x5, x6, it should fall in class B, it is known to us. Likewise, we have many data, we know which it is fall in which class, it is known to us. Now we try to find out this x1, x2, x3. We see we assume a particular k value and we see which class we get. If we get class A, then it's good, whatever we expected, we got that. So likewise, suppose we took 15 such, suppose we took 15 such data for which class level is known to us. We took a particular k and accordingly we predicted the class. Then we out of these 15, how many of us gave the correct result, we'll see that. Okay. Then again we increase the value of k, and we see out of this 15 how many of us that gave the correct result. That way we will do different experimentation on k and we'll find out choose that value of k which gives the highest accuracy. This is one technique of taking the determining the best value of k. So when dealing with a two class problem, it is better to choose an odd value of k. When there are two class, always it is advisable to choose an odd value for k. The value of k must not be multiple of the number of classes present. These are some of the constraints. Okay. Choose the optimal value of k is by calculating root n, where n denotes the number of samples in the training data set. One way of selecting k already I have mentioned. These are some other techniques. You can, one way is that definitely that's the best method which I have just mentioned, and another, if you don't want to do so many, because training data maybe you have around 200 training data which you want to use and try and find out the value of k. So many times you'll have to do it, take one values of k, then okay, you try second values of k. So that is definitely the best method. Otherwise, if you directly go for taking a value of k, so these are the different steps. Choose an odd value if it is 2 class. K should not be a multiple of the number of classes, and k it is advisable to select k as a root of n, where n denotes the number of samples in a training data set. K with lower values such as k is equal to 1 or 2 can be noisy and subject to the effect of outliers. If we take a very less k value, it can be noisy and subject to the effect of outliers. There are some variables, like yesterday in my last class I have given you an example. Suppose I have one class of cat, another class of dog. So cat also has four legs, one tail. Dog also have 4 legs, 1 tail. And some dogs, again, there are some dogs whose height is almost same as the cat. But usually dog's height is more than the cat, right? So this is not an outlier, but there are some dog whose height is less. But I am just to give you an example. So likewise, there will be sometimes some attributes which basically we get some value of the attributes because of some outliers, which is usually not normal, because of some abnormal situation, or maybe because of some very rare situation we get those values. And if we select k value very small, suppose 1 or 2, we tend to we may select a wrong classes because of this outlier values. We will find a very good match with the first data because of this outlier attributes. Maybe actually that is not the class of that. So it is always advisable to take a higher value of k. On the other hand, k with larger values in most cases will give rise to smoother decision boundary, but it should not be too large as well. If you take k value too large, the whole sample size only, the whole training data size, then what will happen? Lots of calculation. It will take a long, because calculating Euclidean distance for each and every point, it will be very computationally intensive. So you should not be very large also, but then a large value of k is advisable. It gives a very smoother boundary, decision boundary. Otherwise, groups with fewer number of data points will always be outvoted by other groups. Okay. So some pros and cons of KNN. Pros: it is easy to understand and simple to implement. We have seen how easy to understand. It just find out the training data, sort it, find out the k nearest neighbor, which is the how many representation, the class which has the highest representation belongs to that class. It is so easy implementation. It is ideal for non-linear data since there is no assumption of the underlying data. Data can be any format. Okay. Since there is no underlying assumption, this classification works very well for non-linear data as well. It can naturally handle multi-class cases. It can perform well with enough representative data. Okay. Then what is cons? Associated computation cost is high as it stores all the training data. It has to store all the training data, it has to find out the Euclidean distance of all the training data, so as its computation cost is very high. It requires high memory storage, need to determine the optimal value of k, prediction is slow if the value of n is very high, and it is sensitive to irrelevant features. Sometimes some classes have some irrelevant features, some very uncommon features. And it becomes, the bad thing is that it becomes very sensitive to those irrelevant features also. We consider those irrelevant features also important. And the term curse of dimensionality means if the data is of high dimensional. So if the data is of high dimensional data means many attributes. For a tuple has many attributes. Suppose a tuple has 100 attributes. Then what happens? We have to find out the distance. You can imagine the time it will take to find out the distance of its 100 attributes. Okay. So this KNN suffers from the curse of dimensionality. With the increasing number of features, time complexity of the distance computation largely increases. Obvious, isn't it? We have to find out the distance of such high dimensionality. Our disk computation is very, very computationally expensive. KNN does not work well if there are too many features. Hence, dimensionality reduction technique like principal component analysis, feature selection must be performed during the pre-processing. So, if we are interested in using KNN classification algorithms, if the number of features are huge, usually that is the case, usually it is seen the number of features are huge, then what we will have to, we will have to reduce the features. There are different methods of reducing the features. We will have to reduce the features during data pre-processing. Okay. Principal component analysis, which I will not be discussing in this lecture. So, way of feature reduction is that one way is principal component analysis. Basically, from the different, suppose there are 100 features, out of 100 features, some feature sets are redundant. Again, there are some dependency in some feature set. So, suppose, let me tell you, suppose there are feature sets, suppose say X, Y, Z, okay, A, B. Suppose these are the different features and for one observation. We have total 5 features for one observation. In this feature, suppose if we have seen if X increases, Z also increases. Okay, or if X increases, Z decreases. So, there is a dependency between these two features. Okay, when there is a dependency between these two features, then why we will consider these two features? That means this feature will have an effect on the class, that we understood. This feature means to find out the class, which class it belongs to, we will need to consider these attributes. We have seen we will need to consider this attribute. But if we consider only X, that is sufficient, because X and Z are very much correlated, either positively correlated or negatively correlated. So, we can just ignore one. Though this we can find out, given the feature set, we can find out which of the attributes are correlated. If the attributes are correlated, we can ignore taking all the attributes. That is one way of reducing the features. Okay. So, that is how basically if there are too many features, again there are some features which does not have any effect on the class level. So, why unnecessarily drag that features, unnecessarily find the distance with features. So, there are different ways how do we find out, how do we reduce the different features, different attribute set. So, once we reduce the attribute set, then KNN becomes quite good. Then it doesn't, its main problem is the curse of dimensionality. Okay. So, now coming to the end of this KNN classification, we learned about a distance based classifier, which we call it a K nearest neighbor method. This is the very simplest classification technique. In fact, from all the classification, this is the simplest one. In fact, for Bayes theorem also, I will not say it's simplest, we will have to calculate different probabilities, right. So, and it is widely used in many applications. So, we learned the KNN classification method, the salient properties of KNN, its advantage and its disadvantage. So, now is the time for tutorial. In the next class, we will have a tutorial before going to other classification strategies. So, these are the references. Thank you guys.